What's up everyone, Patrick here, welcome back. And in this next question, we have to solve for x, y, and z in these three equations. So as we showed with videos before, multiple ways you can go about this. You can do substitution, elimination, you can put it in a matrix. In this particular one, notice how we have these z's here, where the leading coefficient in front of all of them is 1, 1, and -1. And when I see something like that, where the leading coefficient is the same, so let's say we had maybe like 3x, 3x, maybe -3x here, I usually like to do elimination then, because then it's just super easy to, for example, subtract these two, and then these z's are going to cancel out, and then maybe you could add these two, and then these z's are going to cancel out because they have opposite signs. So when I see something like this, I usually like to do elimination. You don't necessarily have to. You can do substitution as well. So you could isolate for something, then plug in, and then plug that expression into the other two lines. So whichever way you go about it, which I actually recommend you doing, pausing the video, trying it yourself, seeing if you get the same solution. But personally, what I'm going to do is I'm going to do elimination and get rid of these z values. So I'm going to create two equations from this. So with these two lines, I could take this line and then subtract this one, or I could take this one and subtract this one. Doesn't matter which way you go. Personally, I'm going to take this line and subtract this one from it because I notice that these coefficients are larger than these ones. And when I do that, subtract this from this, then it's going to allow me to have positive coefficients in front of the x and y. Again, it doesn't really matter. You're going to get the same solution anyway at the end. But that's how I go about it. So if I take this line and subtract this one, notice we'll have 3x minus x. Actually, you know what? Let's number these so we could keep track of what we're doing. So if we do 2 minus 1, we'll go 3x minus x, which would give us 2x. Then we'll do 6y minus y, which would give us 5y. Z minus z is 0, as we wanted. We want to get rid of the z's. And then 7 minus 9 gives us -2. So we got one equation there. And then with these two, let's just add these to get rid of these z values. So we'll do 2 plus 3. And you don't necessarily have to do this combination that I did. So for example, you can do this line plus this line, and then you could do maybe this line and plus this line. So it doesn't matter which way you go about it, just as long as the two lines that you're working with here, the combination is different, right? So you can't like subtract this line from this one and then take this one and subtract it from this one, right? Then you're going to end up with two of these same lines here. So you got to make sure that when you do this, that all three lines are being used. So 2 minus 1, and then I'm going to do 2 plus 3. So then what will happen here? 3x plus -2x would just give us x. 6y plus 3y would give us 9y. Z plus -z would give us 0 as expected. And then 7 plus -21 would give us -14. Like that. And now we have two equations and two unknowns, x and y. And to solve that, what I'm going to do is I'm actually going to isolate for this x. So here I'm going to use substitution because this x here is by itself. So I'm going to bring the 9y over, and then I'm going to take this and plug it in for this x. So we'd end up having 2 bracket -14 minus 9y plus 5y is equal to -2. So this would end up being -28. Minus 18y plus 5y equals -2. And then from here, bring the -28 over. -2 plus 28 would give us 26. And then -18y plus 5y would give us -13y. Then we could divide both sides by -13, like that. To get the y by itself, the y would be -2. And then it's easy to get the x value. Plugging in this y value here, we'd end up having, let's do it over here actually, x equals -14 minus 9 times -2. and this would be negative 14 plus 18. So the x value would be 4. So we have the x value and the y value, and then we could get the z value from either or of these equations. Any three would give you the same z value. I'm just going to plug it into this one. This one's the easiest to work with, I feel. So we'll have 4 plus negative 2 for the y value plus z is equal to 9. So this would end up being 2 plus z is equal to 9. So z would end up equaling 7. So notice how there's a unique solution. These lines here intersect at one point, and it intersects at 4, negative 2, and 4, negative 2, and then 7. Right? So that there is the final answer.